Mr. Beacon podcast is sponsored by Williot, scaling IoT with battery-free Bluetooth.
Welcome back to the Mr. Beacon podcast. We're wrapping up the Cooper Partner event, and I'm here to talk with Fabio Belloni. Welcome back to the show. I think this is like your third time on. And we're going to cover a number of things. I want to talk to you about where the industry is, what Cooper's been doing in the last year, a lot of changes. But the first thing I'd love to do whilst we're here is to show people angle of departure. We had Ken on the show a few weeks ago, and he was talking about the difference between AOA, angle of arrival, and AOD, angle of departure, and that's all theory. I'd love to see this in practice, and you actually have it running here today, right?
That's correct.
So to do this, we have a phone. It's a very large phone. Do you want to hold that?
Sure,
and we
absolutely.
can demonstrate. And so
Thank you.
just recap for us a little bit and explain briefly the difference between AOA and AOD, and then take us through this setup here.
Right. So we are here at the Cooper Partner event 2019, and what we wanted to do here was to showcase AOD, which means having a locators with a single radio that is broadcasting a BLE advertisement packet, and while doing so, switching through all of the antenna arrays. So that's why we call it beacon on dope, because while a beacon has a single antenna that is used as broadcast, now we are using the multiple antennas and the antenna arrays to be switched through the device at transmission.
So it's the same hardware. You've got, is it 8 segments in your antenna?
A number of segments.
Antenna, with one radio. Normally, with angle of arrival, you're listening, but in this case, you've switched it around and you're broadcasting.
Correct. It's exactly the dual mode. So what is happening, the locator are transmitting, think it of as a satellite in sky for GPS. So they are providing a signal, the enablement signal. And then in here in my hand, I have a prototype of a futuristic phone.
Okay.
Where this phone is having a display.
Yes.
Is actually running all the positioning engine instead of on the phone CPU on a Raspberry Pi.
Okay.
Is running our Cooper positioning engine, and is feeding all the IQ sample, which is effectively what the Bluetooth 5.1 standard core is about. So in here we have a receiver board that is running Bluetooth 4.0 plus all the Cooper proprietary implementation to be able to compute the IQ sample, which are then fed into the Raspberry Pi. The Raspberry Pi is running our positioning engine, is computing our coordinates, and then in here we have them on display.
And so the use case here is we're doing, rather than doing RTLS, asset tracking, we're doing indoor position systems, sensing, indoor position sensing or navigation.
Correct.
And you've taken this Cooper location engine, which is normally running on a server somewhere, and you've got it actually running on this very large phone.
Exactly. So the idea here, what we wanted to demonstrate is that if you have, for instance, an AOA setup, exactly as you said, tag, locator in AOA mode, and a server computing everything, we could at the same time also provide AOD to, for instance, mobile handset. That could be phone, tablet, anything. And this device is just a futuristic device.
Right.
Later on, everything that is here on the back of the device will be shrunk to the size of a silicon, of a chip. The important thing to recognize is that, for instance, a phone, the screen already is there. The CPU, which is the equivalent of the Raspberry Pi, is already there. The single antenna is already on the device, and the only thing that is needed is the 5.1 BLE chip plus the Cooper positioning engine, so the algorithm will compute the coordinates. And every device that would be in the area will be able to compute its own location. This is massively important because there is no capacity limit. So you could have, similarly to GPS, an unlimited number of devices within the same area, everyone computing his own positioning, and at the same time the phone will own its own data because it doesn't need to share it with the network, which means an inherent protection for security similar to what you have for every mobile device nowadays.
So I could have a stadium with 100,000 people in it, and you might have maybe 100 locators or less in the ceiling. Everyone would have the next generation iPhone or the next generation Android phone. It would be very similar to the phone they've got today, but it would have a 5.1 radio, still one antenna, but the latest radio. And if they were running the Cooper positioning engine on it, then they'd get much better indoor navigation.
Correct. Effectively, one day, the whole enablement of a phone to do AOD is practically a software update.
Right.
It would just mean maybe a mobile app that would be downloaded, and then the mobile app could run the Cooper positioning engine.
So for customers that already have your locators deployed because they want to track the assets that are in the stadium or in the factory, can they use the same hardware to do RTLS and use it and switch it around simultaneously so that it's sending and receiving, so it's tracking tags that are on assets, but also sending out the signals so that people with these phones can do indoor navigation?
Short answer, absolutely yes.
Okay.
That's the vision. So Cooper's been building from the very beginning, keeping AUD and consumer market in mind. So we wanted to make sure that all of the technology that we have rolled into the market together with our partner during the years could be built so that it could support the new AOD standard whenever making it available. We are doing our best effort in making that happen, and the new generation of locator is a testament into that. So we are trying to keep into consideration with the Q17, which is the new generation Q devices that were launched here at the partner event. We wanted to ensure and make sure that they will support all the new standard upcoming. And the idea is really to have this convergence of use cases so that the single device could be an enablement for RTLS, real-time location systems, as well as for IPS, indoor positioning system, all in one devices, because the more use cases we can provide, the better value is going to be for anybody within the value chain.
So we've got this infrastructure. It can be working in these two modes, time slicing between RTLS and indoor positioning. So are we stuck waiting for Apple and Google to put this into phones, or are there other applications where you can use indoor positioning?
That's a great question, and the answer is again yes. Luckily there is. So for instance, robotics and any device that is out there that would have the computational capacity and could run similar to a Raspberry Pi, the Cooper positioning engine could practically be enabled already today to compute his own location by making full use of the angular departure methodology.
So I could have a delivery robot that is delivering food from the concessions to me when I'm sitting in my seat. It could arrive and it could be navigating around with its own location tracking engine running in its brain.
That's exactly how it would go. That's exactly. It's
I like this.
Pretty powerful.
Okay, well let's have a look at this very large phone and do some navigating.
All right, thank you. Yeah, just follow me.
Okay.
So we are here at the partner event, and we have two locators in the ceiling. Both of them are battery powered, so there is no connection to any kind of network. So the devices are broadcasting an advertisement packet through the antenna array, and in my hand I have the phone, this futuristic phone, which is computing its own position. And in here on the map, we see my position in real time.
Okay.
Noted that the position is completely invariant with respect to rotation.
Okay,
of the
you're
device.
twisting that around and the dot is still
just
in the same
there.
location.
And the reason is because the device only has a single antenna. The multi-antenna is actually on the ceiling, and that device doesn't move.
Right.
Similar as GPS.
Okay.
Exactly. So in here, I can show that as I move up and down this aisle, or whether I move closer to the wall,
yes,
or further away from the wall,
yeah,
then the dot is following me.
All right.
And here we are again.
So very cool.
On the other side.
And so you used an analogy in your presentation, which I thought was really good, which is the analogy of sound. If I was a blind person and I could hear these sound beacons, I would, using my two ears, I would be able to orientate myself and know where I was, because I kind of know where this sound is coming from. I know where that that sound is coming from.
Correct. So there is a strong analogy between radio waves and acoustic sound, and in that explanation we try to convey in very simple term the fact that the AOD and AOA, they are actually mutually complementary system. It just depends on whether you put the multi-antenna system in transmission or in reception mode.
Wonderful. Okay, well, thanks very much for that. Let's go outside and let's catch up on what's happening with Cooper and a little bit more about where these standards are going.
Okay, thank you so much. Thank you.
So Fabio, thanks for that demo back there. I think you really brought out the difference between AOA and AOD. Let's catch up. It's been a year since we've spoken, at least a year. What's happening in terms of your product, new announcements, that sort of thing?
So we are seeing that the market that is accelerating fast. We see the announcement that BTC has brought in the end of January, really kind of sparkling new ideas and new interest into IoT, localization, smart building throughout all the different verticals. So what we have announced during this partner event here in Helsinki is actually the new family of Coupa products, which we call the Q generation product.
All right.
So we have a new family member that is called the Q17.
And why 17?
So we are engineers, so we tend to be not very creative with the marketing name. So 17 is the diameter of the locator.
All
so
right.
17 centimeter
So
across.
that's smaller than the...
Correct. It's a 30% smaller than the old locator. It's completely new design. We have taken a lot of feedback from the field into consideration, starting from electricians and field engineers that has been deployed thousands of locators throughout the past years. They gave us a lot of valuable feedback. Everything was kept into account, completely different design to be more sleek, and then inside is a completely different product. We now have 2 radios instead of 1, so that we can do more exotic things. One radio would be fully dedicated to the AOA and AOD part. The other radio could be used for multi-purpose.
Okay.
And one of these could be, for instance, connectivity towards tag, more like the IoT over-the-air firmware upgrade, collecting sensor data, or doing some of the most exotic IoT-related features or enablement that would require, for instance, connected devices.
And any change in cost?
That's something that we haven't yet opened up, but actually there is some very new business model and price model that we are proposing to our partner that should and will help all of them to get started. We have noticed that some customers are very keen to operate under a CapEx model. Other customers, they are more into a subscription model. So we haven't reached the portfolio and possibility for partners to start work with our product in the best settlement way.
Yeah. So some just touched on the locator changes. What about on the tag side? Any changes there?
So the tag side is getting more and more exciting. So we are getting more and more company and partners. In here we have 12 companies showcases all of their product, different tag, different form factor, different sensing capabilities, and all of our integrator partners, they are very excited to see all the portfolio of opportunities that there are in order, because they think often that one tag types equal a new use case.
Okay.
So that on the front line. What Coupa is doing is to work very closely with more and more silicon vendor to be able to provide the enablement for all of the different vendors, tag vendor and silicon vendor, to be fully Coupa compatible, and that opens up to the whole ecosystem of AOA.
So in the past, you just supported Nordic chips, is that right?
Correct. In the past, we focused on Nordic, and we have done great things with them. Coupa is agnostic with respect to the silicon and radio technology, so our decision originally was simply business driven. But we started to get more and more requests towards supporting multiple silicon vendor. So for instance, we will have soon a TI chip that is going to be supported, one of the latest, and so there will be others soon going to be announced, not yet.
Okay, so a lot more choice on the tag front. So the Contact IO guys were there, so this is You made an announcement with them. That's pretty exciting.
Correct.
It's a sign of you've got just a really rich set of options, a lot of different kinds of vendors. Okay, so that's the product. Let's go back to this standard stuff, because I think everyone's recognized that Cooper has been the leader in angle of arrival with Bluetooth. And everyone was wondering, when is Bluetooth going to go from just supporting the transport to actually the AOA and AOD, and it's happened. That's what 5.1 is. Where does that leave Cooper? Is that a good thing or a bad thing from your perspective?
We are super excited about the new standard. Actually, our CTO, Antti, was the original contributor to the first version of the standard.
This was like 8 years ago or something.
Yeah, exactly. I think that we submitted the first version of the standard specification was 2009, 2010. We've been waiting for a long time into that to come into completion, and now that the core is out, we are extremely happy to promote the new standard as the way to go for the future. The new standard is going to make Bluetooth much better than what it is today. It's going to enrich the capabilities, and the angle of arrival and angle departure methodology is going to open door to new use cases and applications that otherwise at this stage they are not really feasible.
From my perspective, you guys have had the best solution in this space for some time, but in some senses the fact that you were really the only player here, I think, limited the size of the market. And from my perspective, having a standard and inevitably there's going to be competing vendors, you're now in a category which is being established by one of the biggest brands in the world. So I think it's now going to be not a question of what is angle of arrival and is it a good thing, does it work? It's like, okay, angle of arrival offers us this high precision at a low cost. It's not ultra wideband. It's a lot better than these other things. Who do we go for? And then you have this playing field which is set up for you to prove yourself. So that it's likely that there will be competitors coming in. How do you rank your kind of classic Cooper protocol, which you're still going to be supporting, I understand? How does that compare to 5.1? It's all Bluetooth. You support Bluetooth. 5.1 builds on top of Bluetooth. But what you're selling now is not 5.1, is it?
Correct.
No one has 5.1 today.
Correct. So we have been building the whole angle of arrival and angle of departure capability starting from the Bluetooth 4.0. And then from there we just build our own proprietary profiles that allowed to make the overall technology run. So the 5.1 for us is an exciting road because it will open the basic enablement already into commercial and consumer devices. So that's the exciting part. We are intending to support both the legacy device, meaning from 4.0 upwards using proprietary, as well as this new standard. And that's why the new locators, the new Q generation locators, they are really built with that idea in mind. So we believe a lot into what we call use case convergence. That means that we want to have a device that is able to run both RTLS, real-time location system like asset tracking, or having phone and tag emulation, together with the indoor positioning system, the IPS, which practically means wayfinding, which means everything related to tracking mobile devices like mobile phone, tablet, computer, anything that is out there. So effectively try to catch both sides of the curve.
Okay, I'm going to put it to you a little more directly. From what I see in 5.1, which I think is a very good thing from the industry, more choice is good, but what I see in that protocol is it's chatty. It's a conversation with the beacon it's a conversation with the tag rather than just sending out a beacon. And in practical terms, that means you're going to chew up the battery life of the tag. So I think we as a Bluetooth community have to answer that and see how we can take the Bluetooth direction finding standard forward so that it can can really preserve the battery life of
Yes.
the tag. Is what I've said fair? Is that?
No, I think that what you said is absolutely correct. There are a lot of things that needs to be kept into account, and also the fact that the 5.1 is now released to the core. The profiles are still open, they haven't been frozen, and there is still a lot of work that needs to be done in order not just to freeze the current version profile, but potentially improve them to the point that they will cover a broader spectrum of use cases. Because when you go, for instance, into pure asset tracking, you want to keep the radio packet short because that means to increase the capacity of the system. You want to also have not just connection-oriented profiles for trackability and tracing the device. You want also to have connectionless, because if you start to think about pure industrial, you have 20,000, 30,000, 50,000 asset tracking an environment. It has to be done in a very light way.
Okay, so hopefully in the future we'll go from connection-orientated direction finding to connectionless to get that scalability and efficiency. But in the meantime, there's going to be a lot of vendors that are coming out with angle of arrival hardware. What is it that, does that mean that they're going to have the same level of accuracy as you guys, or what?
We have been working for about 15 years into building the AOA and the AOD to the point that it is today. If you think about what the standard is providing, is really the smallest building block, which is the IQ sample. So if the IQ sample is somewhere here and having the dot of the matrix coordinate is up there, practically there is a lot of work that needs to be done to convert those raw sample data to angular measurement, to positioning measurement. And on top of that, there needs to be all the collateral tools that allowed to plan the deployment, commission the deployment, telemetry, monitor it, do everything that would make the system highly scalable. So from our side, and our vision is that in the future there will probably be still the Coupa proprietary profiles in use, because those one are also more power efficient than at least the current version, where you have long packet that needs to be transmitted. To your point of being more chatty, that's exactly what will turn, because the radio needs to be open longer. So, but at the same time, there will be a lot of devices that will inherently come out of the factory being fully 5.1 compliant. And from Coupa side, to the point of use case convergence, we want to be able to support as many devices, Bluetooth devices or use cases that are out there, so that one single piece of infrastructure could run anything up to the imagination of the system integrator.
So I think two things came out of what you said. One is there's a lot of IP in higher levels of the stack. So yeah, you can have 5.1 compliant antenna radio system, the low level, the IQ samples go up. But then there's all this software that's running that you've been developing. And then I think what you hinted at is the idea of maybe the Coupa engine could potentially run on other people's hardware. Does it, because I can imagine if I'm a big access point vendor, I've been struggling with location forever, I'm just fed up with all these complaints. Now I have a standard, I can start building the hardware, but how do I catch up on this software side? And the obvious thing is license it from you guys. Would you guys be open to that kind of business model?
Actually, yes. We would be happy to discuss about those opportunities. In the past, we have been more closed into possible OEM integration, but I think that this is the right time for us to open up to that possibility. And one of the key reasons is because all of us want to accelerate the market adoption. We want to make sure that within the whole value chain of infrastructure provider, mobile phone and equipment provider, and the system integrator, the venue owners, and the end customer, they all should benefit from having this new technology in their hand. But you cannot deny to have any of those 5 building blocks. So we are excited into trying to accelerate the market as a whole, and we believe that find the right partner to which we could do a possible OEM integration could be a win-win, because we could bring into the table many years of work and development, and practically allow them to frog jump into the 2-day world without having to do that heavy lifting. What we could do is not just provide all the algorithm part and the software, but there is also a lot of know-how related to the antenna array design itself, because opposite to other standards that in the past were released as part of Bluetooth, where effectively the basic communication part and protocols were pretty much set, and the antenna design or some part of the hardware design were not part of the core enablement. The 5.1 AOA and AOD are different in that sense, because even by having a 5.1 chip doesn't mean that you can do AOA or AOD. You still need to have the antenna array, which is a core part of the overall system.
Yeah, as a solution architect, that possibility really excites me, because to your point, I think it's going to allow adoption to go much, much faster, and that's going to benefit the whole ecosystem. And really, if you're looking at optimizing a factory, a retail environment, you should be deploying angle of arrival, but I just can't see, you're not going to have hundreds of thousands of customers buying your hardware, even though it's an amazing product. And so if you're going to scale up quickly, I think working through the folks that have already got that base, have got the contractual relationships, and going to be trying to make this new solution work makes a lot of sense.
Yeah, we are more than happy to talk, for instance, with AP vendors, talk to lighting company, to talk to company that provide speakers, anyone that would provide some infrastructure in the building to try to make those infrastructure richer and more aligned to the new positioning technologies.
So let's just talk a little bit about industry segments and some of the alternatives. Now that angle of arrival is becoming established as its own category, what is that? What's the competition like? What are the alternatives like? And where is this technology going to be deployed? What are the market segments that you think that you're seeing the most growth in?
Yeah. So historically, we have seen Bluetooth gaining a lot of traction for anything that is related to IoT. And typical IoT could be smart building, could be hospitals, and all of that. But the interesting part is that we see industrial IoT getting much more open into the adoption of Bluetooth technology. So in the past, that has been a market segment that was smiling more towards ultra-wideband, but they started to realize that Bluetooth is not just a consumer technology. It's actually a technology that can be well adopted into highly secure, mission-critical, harsh industrial environment, and they can provide the same level of reliability as ultra-wideband, with the advantage of having full compatibility into most of the devices that are actually already deployed on the floor. And a testament to that is that as part of our ecosystem, we are getting more and more former and current ultra-wideband technology provider that they want to expand their own offering towards their end customer and embrace CUPA technology with Bluetooth as an extension of what they otherwise are already providing. So Bluetooth, we are seeing it on a daily basis that is reaching places that before they were looking prohibited for them. So the market is getting more educated, and industrial IoT is becoming more closer to the adoption of Bluetooth.
So to give ultra-wideband its due, it's been delivering high accuracy indoor location RTLS for some time. It's been used by most of the big luxury car manufacturers have used it. If you're making a product that costs $100,000, you can afford to put an expensive infrastructure in. And in my mind, that's the disadvantage of ultra-wideband. Historically, it's been super expensive. It seems like it's coming down in price, but the other thing that I've seen as we've evaluated this technology is that it burns through battery on the tags in a major way.
Correct. And don't get me wrong, I don't think that ultra-wideband is going to fade off
it's
of
not
the
going to go
industrial
away.
environment.
No.
I think that it's going to stay there, and they're going to find a long life across a lot of use cases.
Yes.
But what the industry sides are doing is that in a factory is not just about the production line. There is a lot of other things to be tracked outside the production line, in the parking lot, in the warehouses. And that's where Bluetooth is finding more fertile ground towards expansion into industrial IoT. So I think that the two technology will very well coexist in the future.
Yeah, I think that's great. It's so easy to turn this into a tabloid. This is better than that, and it really is the right tool for the right job. So, but I think that's not to understate what is potentially a massive wave of adoption of Bluetooth AOA because of the much lower cost. I mean, what I've seen is an order of magnitude less in terms of cost. That's not always going to be the case. I think UWB is really driving the cost down. So I think it's safe in its kind of premium segment. But what you guys are able to do with tags that last for years is something that's very hard for ultra-wideband to meet. And obviously, from my selfish point of view with Wiliot, we see the opportunity to bring the tag price down from dollars to cents. And it's going to be impossible for battery-free passive technology to work with ultra-wideband. It just doesn't, the physics won't work. So I think it's really nice stratification of the market, and you guys are in a great position to benefit. And more importantly, I think it's really going to change the way industrial IoT is done.
Yeah, we see that in the industrial space there are more and more sensors or tools, and all of those are already BLE enabled. So having a technology like AOA and AOD will practically allow to bridge both the Bluetooth gateway for remote sensing together with the high precision tracking. Plus, another interesting use case that is coming up in industry is paperless factories. So paperless factory is inherently enabled by tablet, mobile devices, which are all anyway coming out fully Bluetooth compatible. And that's where having the AOD available also in those environments will kind of close the loop. So it's going to be an exciting ride going forward.
Very good. Well, it's been an exciting few days. Thanks for these insights, and look forward to next year's event.
Thank you very much, Steve. Thank you.